So welcome friends to AI Club today, and thanks for joining on a Saturday afternoon. So I think we have already completed a major portion of deep learning, which is our ANN and CNN. So CNN was the major part. So we have already completed that. So we can say that more than 70% of deep learning is already complete. So this is the last leg of our deep learning course. And in that, we will be covering something called recurrent neural networks. After that, we'll be taking some classes on transfer learning. And the last class will be for some advanced topics in deep learning, which are the most basic concepts, I think, which most people have some are the other confusion. So I have kept those topics like optimizers and many other such things into the under the head of advanced topics, and we'll cover it in the last. Okay, so maybe 3-4 more theory classes will be there, and I will be taking theory classes, and Soman as usual will be covering the coding part. Okay, so we start here with RNN. So first of all, what is RNN? So RNN stands for recurrent neural networks. Recurrent neural networks. So as you can imagine by its name, it is something reoccurring. Something reoccurring. So I'll tell you what reoccurs here. So basically, RNN is a specialized neural network which deals with sequences. So what is meant by sequences? I tell you someone is a good boy, or say Dr. Shailesh is very learned person. When I say this, what happens? All my words in this sentence are arranged in a sequence. I cannot alter the sequence of these words in that sentence. So if I say someone is a good boy, and if I say someone boy good or something, if I alter the words someone boy good is something, then the sentence will lose its meaning. So sequence is something where order of events is very important. So we can use RNN for a sequence of words like sentences. We can use RNN to resolve the sequence of numbers, maybe like usual AP, GP, arithmetical progression, geometric progression. These are very simple things, but very complex kind of number sequences also we can resolve with the help of CNN. And one more very familiar example I want to give you is video data. So like videos what is video actually? So video is nothing but more than 6 frames per second they are throwing in more than 6 frames they are throwing in front of your eyes. So your eyes cannot distinguish. So they are individual photographs actually. These six individual images are being thrown in front of your eyes within a second. So your eye cannot differentiate that these are six different images. So it assumes that it is a continuous sequence, like if you are moving hand like this, and in one sequence hand is here, one here, one here, one here, one here. So if you throw more than six images per second to your eyes, it will assume that it is a continuous motion. So generally in our videos, we throw with the speed of around 20 images per second. That is a standard video. Like video in the standard videos, we throw around capture around 20 images per second, and we throw in front of your eyes also 20 images per second. So in your eyes cannot distinguish between the sequence of images. It assumes that it appears that it is a continuous sequence. So video is another very familiar example of sequence. Word sentences in any language, they are sequence based. Then another example I can give you is stock exchange data. Like stock exchange starts, I'm not sure exactly what time. So let us assume it starts at 8:30 in the morning and closes at 3 p.m. in the afternoon. So the stock movement we see, so that is also a sequence data. So stock movement of 8:30 was price was say 130, then price increased to 145, then again is dropped to 142. then again it dropped to say 141, and then again it increased to say something 152. So that is the kind of sequence data we are familiar with. So there are many other sequence example we can take. The audio which you are listening from me, that is also sequence data, right? Then audio, video, then video, audio, meteorological data, DNA sequences for biology people. So DNA sequences, actually, I'm not a biology person. So, but like DNA, what the way DNA sequences are arranged is also sequential information. So all these kind of sequences, whatever is the domain area, we can analyze with the help of this specialized neural network called recurrent neural network. Now you will ask me next natural question that why can't we analyze sequential data with the help of a artificial neural network ANN or a convolution neural network CNN? Why cannot we use a ANN or CNN to analyze sequential data? So let us first take the example of ANN, which is artificial neural network. So a very basic assumption in artificial neural networks is all the features which we are giving. So in a sentence we say Soman is a good boy. So Soman is a good boy. So if I remove is and a, which are usually we remove such words, is and a. So Soman good boy. There are three features in this. Soman good boy. These three features are there, right? So in our sequence, they are dependent on each other, one after the other. But in artificial neural network, very basic assumption is that all our features are independent of each other. So I write Soman, let me write it, then I will be able to pronounce it properly. So Soman is a good boy. Okay, so Soman is a good boy. Suppose instead of that, I will write. So now Soman is a good boy. It is a sequence making meaning to us. Then if I write it, Soman, good, A is boy. Soman, then I pronounce good, then A is a boy. So I disturb the sequence. Okay, so I disturb the sequence, but then sentence will not make many. Sentence will not make any meaning. But for ANN, it doesn't matter whether it is Soman is a good boy or Soman boy a good is Soman boy a is good. Like that, whatever sequence you take for ANN, it doesn't matter, because in ANN our basic assumption is that all our features are independent. So we cannot we are violating basic assumptions of ANN if we are taking sequential data. Analyzing sequential data, if we are using ANN, we are violating our basic assumption, and then our results may not be reliable. So ANN is ruled out. Then what happens in case of CNN? So CNN, if you remember, we do some kind of say filters. We use filters and pooling. So filters and pooling, if we use, so they preserve some kind of local relationship between nose and mouth, nose and eyes. So this kind of relationship is preserved when we do convolution with the help of like filters and pooling. When we do, so even in pooled image also, this kind of local relationship is preserved. But still, it is local relationship is preserved. Still, it is not a strict sequence. Like very strict kind of sequence is not preserved in case of CNN also. So suppose, so CNN is kind of a word cloud. Word cloud, you understand? Like some words are there and they are jumbled up. Those word cloud is given, and word cloud is given, and then if we use CNN on the word cloud, then it may make some sense to CNN, but still strictly local kind of sequences, those strict local sequences are not being preserved with the help of CNN also. So ANN, we cannot work with even a line, like, because all features are independent. CNN, some local preservance is there. If we use a word cloud, within a word cloud, we can use CNN. But in kind of strict sequences like someone is a good boy, where we want to maintain strict sequence, we cannot use CNN as well, because that also doesn't maintain very strict sequential dependence. That's why we have devised something called recurrent neural networks. So what happens in recurrent neural networks, recurrent neural network, I have already explained you this. So recurrent neural network works like this. See, you first look at the rightmost train-like sequence. Can you see a train-like sequence in right hand side figure on the top? A, then again A is repeated. So we are feeding a sequence to different artificial neural networks. So all every A is an artificial neural network. We are feeding, Soman is X0, is means X1, A means X2, and good means X3, and boy means X4. Like that, we are feeding sequences. Each word, each feature, we are feeding to one particular neural network. And then from that sequence, that particular neural network, we are getting an output, and we are passing some information to the next neural network. Okay, so it takes the output of the second neural network takes output from the first neural network, which is H0, and it takes input from the first neural network, which is the horizontal arrow, which is shown here. So H0 and the horizontal information coming from the horizontal arrow, it takes, and it combines with the new input, which is X1, and it generates one more output called H1. So now H1 and that horizontal arrow information together is fed into next third neural network. So and it takes into account our third feature, and it generates one more output, which is H2. So similarly we take into account all these things, and we go till the end. So output of the neural network, output of this recurrent neural network is nothing but the output of the last A column. The last ANN is the output of our recurrent neural network, right? So this same thing, instead of showing it in the form of a train, a connected train, we can show it in a very concise form, which is shown here in the two figure. One is wire diagram, and one you can see. So in one xt means time t, we are giving input. There is a processor A. There is a processor A, and then it gets some output and feeds again into same thing. So there is a loop you can see here. So there is a loop, and then it gives an output. So the same is a concise form. We can unfold it in the form of right hand side figure, which is on the right hand side of equal to. So these are two different notations of ANN. One is folded form and one is unfolded form. Is it clear to everyone, Dr. Shailesh?
No. It is actually, how come this X1 means?
See, first you see the unfolded form.
No, but
is it clear? Unfolded. No, first listen. First, is the unfolded form clear to you?
No, it is not clear.
What is not clear in this?
Actually, you mentioned these are all X1, X2, X3. These are all different neural networks, no?
No. X1, X2, X3 are all of features.
Features, sorry. These are all features.
Features. And in between X0 and H0 and H0, there is a neural network. Between X1 and H1, there is a neural network.
Sir, I have a question. Is that a full-fledged neural network, or is it just a neuron?
No, it is full-fledged neural network with all weights and biases and everything. Okay.
Maybe we will park it. Maybe at the later stage we will understand.
What is not understood? Okay, so we'll park it. And no, but you understand, no? Otherwise it will not be clear ahead. So this kind of neural network, horizontal also, it is passing my information to the next neural network, which is your sequence dependent thing, and it is giving one output H0. So H0 and this horizontal arrow is being processed by the next neural network, which is the second column, along with the input X1. And then it is giving an output H1. Then H1 and then horizontal information is being fed into The third one, that is giving output H2. Then like this, we are going till the end. And a simple unfolded notation is like this. Unfolded notation is simple loop of this particular. Soman, can you explain it in a different words so that I think they will get some other viewpoint as well. Our learners will get other viewpoints. Can you explain it in terms of some other language?
Try looking at like this. First, we are training on a sequence, right? So we take each feature, means each part of a sequence as a feature or input feature. So here we have X0, X1, X2, all those are input features.
So Shailesh is a good boy. There are 5 words in this. 5 words in this. So there are 5 features in this. Okay.
Yeah. So
that's how we are counting features.
Yeah. We start with Shailesh, we pass it to the network, we get output at 0. Now, whatever the weights or whatever the processing was done in the first neural network is feed as an input to the second neural network for is. Shailesh is for the word is the weights and all the training of the first neural network is fed to the second neural network as well. Then second neural network uses its input and the extra input from previous neural network as for the training and gives us H1 whatever be the output. This same process goes on repeating. So each time whatever our output is generated, whatever weight matrix is generated, that is passed to the next neural network as well as an input as well.
Yeah.
So does it mean that if I have a sentence with 20 words, then there would be 20 different neural networks?
Yes. 20 columns will be there. 20 like that. It will unfold 20 times.
Okay.
Okay.
And you
and
can
now
go on repeating as well.
Yeah. So now you see. Yes. You complete someone.
Yeah. As ma'am said, if you have 20 words, we can have 20 networks, right? We can actually increase the number of networks. In that tutorial section, you will see we actually have the option to add number of networks.
Okay.
So right now, let us keep it simple. If we have 20 features, we have 20 neural networks. That's it. So now you see, X1 is Shailesh. Shailesh is X0, right? Now Shailesh is X1 is X1 is, right? So is being fed to the second neural network, but from first Shailesh is being from that first neural network also it is taking an input. From first neural network also it is taking an input. So like that you have conditional sequential dependency is preserved. Understand, na?
Okay.
So first time you will find it is difficult, but as things progress, I think things will be clear.
Yeah.
So the same representation here. Another simple representation. Unfolded and folded. Folded on the left hand side and unfolded on the right hand side. Okay. So let us understand a bit of math behind it. So we call it no, I don't want to explain this like this way. So wait a minute. HT f of u xt ht is the weight of xt and wht minus 1 wht minus 1 ht. Okay, so now you take this particular unfolded diagram. Don't get carried away or worry by the notations. So first of all, we denote each feature by x on the top t. So Shailesh is t minus 1, is T, XT, and A means Shailesh is a good boy, means third. Third will be T plus 1. So we have XT in between. We have before feature XT minus 1, then XT plus 1. These are about features. Okay. Then HT is our say processing unit, which is HT, function HT. U is the weight between XT minus 1 and HT minus 1. That is the weight. Consider this as a 2 layers of neural network. So a weight matrix U is sitting between XT minus 1 and HT minus 1. Similarly, a weight matrix V is sitting between output OT minus 1 and HT minus 1. Is this clear? This is weight matrix. U, V, and W are weight matrix. As we pass from one layer of neural network to other layer, we have weight matrix, right? In between weight matrix is sitting in between, right? Every neuron one neuron connecting to other neuron is a weight, has a weight associated with it, right? So it's a overall weight matrix, if you remember, between every one layer to other layer. Do you remember that? As we go from layer one hidden layer to other layer, there is a weight matrix sitting in between, right?
Yes.
Can you visualize that?
Yes, we can.
Yes, we can visualize that.
We can visualize, right? So now you see the equation here on the left hand side in the bullets. You see the equation in the bullet, you see the bullet. Then first of all, you see right hand side of the equal to. So you see in the brackets, HT, you see the middle neural network, which is represented by XT, HT, and OT. OT is the output, HT is the processing function, and XT is the input. So HT, XT, HT, and OT. This middle one you see. So what happens? HT is the input being given to HT. Okay, XT is the input. So it will get multiplied by the weight matrix V, weight matrix U. Understood? So we multiplied feature XT with the weight matrix U. Okay. Then what happened? We got then we get from previous network, HT minus 1 gets multiplied by W, which is the in between sitting weight. HT minus 1 gets multiplied by W, and it is added to X, XT, and U. Is this understood? Weight matrix W and U you see. So XT gets multiplied by U, and HT, which is the previous input from previous network, gets multiplied by W. Both are get added up, and in between there is a say kind of function applied to it, which becomes HT. Is this understood?
Yes.
HT is nothing but input from XT and HT minus 1, from previous network, and XT, and both will get multiplied by respective weights. Very simple. Malini madam, Shrutika madam, is it clear?
So, sir, if I understand it right, the h of t plus 1 should be a function of u into x of t plus 1.
Yeah, exactly.
W to h of t.
H of t into W.
Yeah, W into h of t. That's correct.
And in the bracket outside there will be some kind of ReLU or some sigmoid will be applied to it,
right,
and then it will become HT.
Yeah.
Right, because some kind of activation function will be applied to it, and then it will become HT, and then it is passed on to the next layer.
Okay.
Understood, na, Shrutika madam? Is it understood?
Yes, sir.
It is simple maths actually. So U is the weight sitting between input feature and HT, and W is the weight sitting between the previous network and the new network, and V is the weight sitting between HT minus 1 and OT minus 1. So U, V, W, three weights are there. So we have seen the function of U and W right now. We have not seen the output. We have not seen the output. So let us see how output works. So U, V, W, and then I want to see output where output OT illustrates the output of the network. OT, I want to see the equation of OT if it is written somewhere. OT equation. Yeah. Yeah. So see now this is different different notations. So first equation we have understood. AT instead of so AT just first equation whatever we have learned is broken down into two equations. So first is your AT is nothing but bias plus these two weights multiplied W and U. Then we have applied a 10H activation function on AT which becomes HT. Then HT gets multiplied by the in between weight matrix V and it is added to another bias C which becomes your output. And final output is nothing but your Y output, which is the probability. You have to convert in terms of probabilities, right? So you apply a final layer softmax function, which is OT applied on OT. Are these 3-4 equations clear to you?
Yes, sir.
Let us discuss all these 4 equations if it is not clear. This is nothing but feed forward for RNN. Dr. Shailesh, is it clear?
Yeah, no, it is clear.
See, first of all, it is forming a AT function, intermediate function with W into H, W into H, W into H, HT minus 1 plus U into XT. That is what we have learned earlier also. Then it applies a activation function of the layer which is 10H. Instead of 10H, you can apply ReLU, sigmoid, whatever you want. Depends on your case. You got that? Then each become HT. HT become then on that HT, you multiply the weight matrix V, and add another bias which is called C bias and make it output O. Output O may not be probabilities between 0 and 1. So to convert into that, you apply a softmax function, and get your final output in terms of your probabilities. Understood, na?
Sir, a basic question.
Yeah.
Now, this output, will it be connected to one neuron or something like? This is not a classification or anything like that, right?
Yeah, that we'll see. We'll come to it little later. It is not a classification.
Okay.
It is sequence to sequence conversion, or like I will tell you the basic uses of RNN. Like you are reading a tweet, and you are feeding a tweet into a neural network.
Okay.
So you want to decide whether this tweet is a positive tweet or negative tweet.
Okay.
So that can be a classification function. That can be a classification problem.
Okay.
Now you are translating from English to French or English to Hindi. That is, English also has many words, many features, and output also has many features, right? So that is many to many conversion. So this is many to many RNN.
Okay.
So these are two different kind of RNNs. Understood, na?
Yes, sir. Understood.
And
so this is the basic feed forward equation. Better we understand that actually, and nothing of that we have to do in ourselves. Anyway, computer is going to do it for us. Yeah, Dr. Shailesh.
And all these configurations of all these networks which are we are seeing horizontally, that will be same for all the
network architecture you are asking, right?
No. Suppose if I have H1, O1, OT1, OT2, OT3, na? So vertical are the different kind of neural networks are there, na? So which are connected to different features, right? So all these neural networks are exactly same, or they're also something means just question.
These weights in between weights are same actually. UVW weights are getting transferred across different neural. So neural network weight also will have same UVW weights. Another will also have UVW weights, and third also will have UVW weights.
Okay. And what about configuration of neurons? Suppose one may have 256, another one have 1026 or like that. So that will also be same. As far
Let us park this question for now.
Okay.
At the time of our tutorials, these things will be more clear.
Okay.
Okay. So for now, you assume that these weights UVW are getting transferred from one ANN to other ANN and other to other to other, like that in feed-forward fashion. Okay.
Yeah.
And now that we are interested in calculating loss, right? Whatever is loss, we have to calculate. We take a derivative of the loss and we propagate back across the network, right? So how we calculate loss here actually? The total loss of a given sequence X value paired with a sequence of Y values would be then the sum of losses over all the time steps. So these are time steps like HT minus 1, HT plus 1, these are time steps. So what will be the total loss of our total RNN? What will be the loss of our total RNN? So loss of total RNN will be nothing but a loss in the each time step. We'll add it up. Loss in the each time step will add it up. So that will be our total loss. And our objective from at the time of back propagation will be to minimize that loss. Got it, na? See, in simple ANN, what we do? In simple ANN, we take a difference of difference of true level and the predicted level. We take a difference of that and we take a derivative of that and we equate it to 0 so that we want to minimize it. So here what is loss? Similar loss, each time step there is a loss because each time step is a RNN. Each time step is a neural network. So total loss of this equation will be sum of all the time step together. Loss in first time step, loss in second time step, loss in third time step, like that. When we add up, that will be the total loss of that particular RNN network. Then we differentiate that loss function. We make a loss function. We differentiate that loss function with the help of with respect to weights and biases of the network and propagate it backward to update our weights and biases in every back propagation. So this back propagation process math is very complex, which I'm not including in today's lecture. I'm not including it. Just for the sake of academic interest, I have included what is feed forward. Feed forward, I have shown it. Feed forward is in front of you. Back propagation is not in scope because it is very complex maths actually. So I'll once again explain what we do. Take the case of a simple ANN. What we do, we take the loss of true level and we prepare a loss function with the help of true level minus the predicted level. That is our loss. That loss function we differentiate with the help of every weight and every bias. We differentiate with the help of that and then whatever loss is there, we propagate it backward from output layer to the input layer backwards. And that way, in every step, we update the weights and bias. We update that. That is the back propagation process. And when convergence occurs, the updation of weights and biases doesn't take place. Whatever, say 100 step, weight was 100 and bias was 20. So 101, 102, 103 step also, weight will be 120 only, they will not get updated. That time we understand that convergence has occurred. These things we have to remember only conceptually. So any conceptual challenge in this actually? Shrutika madam, any challenge in this conceptual challenge in back propagation process?
No, sir.
think I'm not able to explain properly. You guys have not understood, or if you come up with questions, that I will be able to tell you better actually. So no questions on backpropagation?
No, sir. So far it is clear. It is similar to ANN, except that now the time, the entire.
Yeah, all the time steps we calculate separate loss, add it up. That makes our loss function, total loss function. Okay, so it is similar to ANN only. Now we go ahead. Then another representation of same RNN. So hidden unit, 1, 2, 3. Time 1 input, time 2 input, time 3 input means time 1 will be say Shailesh, time 2 will be is, time 3 will be A, time 4 will be good, and time 5 will be boy. Like that. Shailesh is a good boy. Like that, time steps are there. For every time step, we have a hidden unit, time 1, time 2, time 3. And for every hidden unit, we have an output unit. And for every, this green and blue arrows, green, blue and red arrows, what we see here, we have weights associated with U, V and W, which are getting transferred across the time steps. So this is the simple architecture of our RNN. And I think this looks very tough, but as usual, coding is damn simple. Just you have to call the RNN function, give some parameter, some upper parameters, instantiate it, and use it. So coding, there is nothing. Only conceptually to understand it, it is a bit involved kind of function and looks very big. That's why people get confused. But it is, if you understand it, it is not much of difficulty actually. Instead of one ANN, we are using multiple neural networks. And why we are maintaining multiple neural networks? Because one neural network processes one input, and it has a dependency to the other feature. So that's why we give this red arrow input to the other feature. That's why we have multiple inputs. One feature is processed by one ANN, second feature is processed by second ANN, and both are connected. That's why we have multiple ANN units, and finally we get the output. So now we go to the architecture of ANN, which is very simple. Different architecture of ANN, like I told you just now one example, like we are reading a tweet about a movie like Kashmir Files or any movie, we are reading a tweet. And there are thousands of such tweets, and we want to decide whether this tweet is positive or negative about the movie. It represents positive sentiment or negative sentiment. So you have, this movie is good. This is a positive sentiment, right? So this blue box on the top will give you one input, yes or no. So this is a sentiment, this movie is good means positive sentiment means this blue box will give you output of yes. This is nothing but many to one RNN. Then another RNN is, it looks very difficult. I will not show you this. Another RNN is used many to many. So these bottom three boxes, rectangles are nothing but your English. Like this is a cat. So A you remove, this is cat. This is cat, 3 input. And output are 3 say German words, equivalent German words. Now you will ask me one question. If I input 5 features as input, like my sentence has 5 words as input in one language, but other language can have say only 3 words for that. Other language can have only 3 equivalent words, but the meaning of the sentence will remain the same. Understood? So that is also many to many, but in that output is not equal to input. So there are 2 types of many to many. One many to many means where input is equal to output, like 3 words input, 3 words output. This is same. And then in some cases, what will happen? Input will be 3 words, and output will be these blue boxes will be only 2. And only 2 boxes will be equivalent to the 3 boxes in another language. So that will also be many to many, but that will be a different type of many to many in which input and output are not equal. Understood? This is another type of many to many. And that is another architecture, like I give a topic. I give a topic, say, whatever topic you want to call, like what is current topic, like Ukraine war. I give a topic, Ukraine war, Russian invasion of Ukraine. I just don't give only one sentence, Russian invasion of Ukraine. And then you are asked to write an essay. As a person, you read many articles, you look into, you watch TV, you listen to many persons, you read magazines, newspaper. So based on your seat, at least one page essay you can write. But same thing is possible using neural networks also. Neural networks also, it is same thing is possible. I give only one input, Ukraine. Just give Ukraine, only one word, Ukraine. So you write an essay from the past of the Ukraine, present of the Ukraine, you write about Russian war. And what you expect the war outcome to be. All these things you write on the word of Ukraine. So these kind of things are being, these type of things are also possible with the help of neural network. So that is called one-to-many. So we have discussed many to one. Many to one means one tweet is given, you have to classify whether it is positive or negative. Then reverse, one to many. One to many means I am giving a topic like Ukraine, output will be many. One essay will be the output, that is one to many. Then many to many. Many to many also two types, in which one many to many in which input features are equal to output features. That is one many to many. Another many to many is input feature is not equal to output feature. So these are the basic type of, these are basic types of RNNs which are available. So in our current course, we'll be covering many to one. Many to one will be covering. We'll be covering many to many with both the side equal, like input feature equal to output feature. That many to many will cover. And we'll cover many to many in which input features are not equal to output. That also will cover. But will not cover one to many kind of RNN, because that is very complex. And for the current course, it is out of scope. So that is something I called GAN or GPT. I think those kind of neural networks are available. GAN, GAN, and GPT, those kind of neural networks are available. Recently, they are available. So they do this kind of job, like you give one word and they will write complete story about it. So that is very complex and a network, and we are not covering this in this course. So understood what we'll cover? We'll cover many to one. Many to one means given a tweet, you classify whether it is positive or negative. We'll cover many to many. Many to many, two types. One is the input feature equal to output feature, and another is output features are not equal to input feature. These three will cover. Okay, so that is meant for beginners. And one to many, given a Ukraine word, one word I give Ukraine and write an essay. So that is something very advanced, and that is not meant for a course like this, which is meant for beginners. So these are the basic architectures of this is one to many architecture. One to many architecture, but this will not be covering. So like generating music. So like it is raining. Evening it is raining. So there is a different music for rain. So you may ask your robot or that musical instrument which is robotic, AI based, you can ask him to generate a music on rain. So that is something one to many. Like some word like romantic music. So there is a category of romantic music, love music, romantic music. So you just give one word love to that particular AI-based music generator, it will generate a music on that. So that is something very complex, and that we will not be covering in our course. So these are the all in one place: one to many, many to one, many to many, and many to many. So this many to many, I have not got the picture actually. So I could have shown you many to many where input features are not equal to the output features. That I couldn't get actually on the net. So drawing is generally very difficult, so I have not shown it to you. But there is one more category which is called, I talked to you many times that I talked to you. So these are architectures, basic architectures of ANN. And now if you want, these are the basic, that's what I meant for today's lecture, class break 1. And I think this is enough for today. And better we sleep over this, and then in the next class, tomorrow class, I will cover more basic, more advanced things like what is bidirectional RNN. Then we'll cover, there is some problem called problem of vanishing gradients, problem of exploding gradients in the case of RNN, because RNN is very complex architecture. So when we do the back propagation, so back propagation is a mathematical thing, right? Mathematical phenomena, right? Back propagation is a mathematical phenomena. So what happens is when we do the back propagation, the gradients become so small, it is so near to zero that your network training doesn't happen. There is no updation of weights and biases because it becomes so small. Because of some reasons, I will tell you tomorrow why it becomes so small. That it becomes so small that on the 1 or 2 layer will get trained. Beyond that, gradient vanishes. It becomes near to zero. So those layers will not get trained because our RNN network is generally very deep. For long sentences, I told you just 3-4 feature sentences. But if your sentence is having 20 features, 30 features, 40 features, which is possible, right? So in such cases, your for 1 or 2, first 2-3 layer it will train because the gradient will exist. The loss gradient, the gradient of loss vector, loss function will exist. But beyond that, your gradient vanishes because of some reasons. Because your derivative is in fractions, and when you multiply it to weights, it becomes further small, further small, further small, and after one stage it vanishes. So no training happens. So no training happens means our RNN failed, right? It doesn't work. And another is the case. Suppose your gradient is say 1.5. Now you multiply it with weights which are more than greater than 1. Then becomes bigger. Then further you on one more layer back you go, it becomes further bigger. Then it goes bigger, 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 bigger. And sentence is very big, so you have many layers in your RNN. So it becomes very, 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 very big number, which is unmanageable. So it is called exploding gradient. So vanishing gradient, where gradient vanishes, exploding gradients means gradient becomes so small, such a big number, that it is beyond managing, beyond your memory of your computer. So these are 2 reverse problems, but both are possible in our RNN. So these are possible. That's why nobody uses RNN anymore. So there are 2 modified forms of RNN, which is called LSTM and GRU. You see LSTM in front of you. LSTM is there in front of you. We'll discuss it tomorrow. What is it? Anyway, coding like when we do coding, only we have to call the function. Everything is done by the TensorFlow procedure. And this is GRU, which is the simplified form of LSTM. This is one. You mind it. This is one neuron actually. This is one neuron, one particular cell of that RNN. So you can imagine if there are so many functionalities in neuron, if I put 200 neurons like this, each neuron will look like this. So it will become very heavy. So LSTMs are very heavy in functionality. So we use a bit simplified version, which is this, that is called GRU. GRU, like gated recurrent units. So I'll explain you what these gates are, where sigmoid function is used. All these things we'll discuss tomorrow. So why LSTM? What is this sigmoid function here? What is this cross? What are these straight gate which is going from top? There is a straight line. What is it? What is this plus? What is this cross? This sigmoid function. And then all this, what is input? What is output? So all these things we'll discuss in tomorrow's lecture. But as I told, it is a theory for you to understand what is LSTM and GRU. But while coding, it will all be done by internally. It will all be done by your TensorFlow or Keras procedure, which you are calling. So RNN there is a procedure, but nobody uses it because of vanishing gradient and exploding gradient, which I told you. There is one more class of architecture which I want to discuss with you, which is called bidirectional RNN. So right now, what we are doing, Dr. Shailesh is a learned person. So we are reading Dr. Shailesh is a learned person. We are reading it in a sequence. So when we are reading Dr. Shailesh, we don't know what are the words behind it, right? And we are processing it, Dr. Shailesh. Sometimes what happens, to make the meaning of first two words like Dr. Shailesh is very clear. But sometimes the sentence is so complex that to make out the meaning of initial words, you need to know the context by reading the future words also. Like, to interpret the initial 2-3 words, you need to know what is the full sentence. And if you don't know the full sentence, you will not be able to interpret first 2-3 words properly. So in such case, what we do, we adopt this kind of architecture, which is called bidirectional. So we feed neural network, we feed a word from both the direction. Shailesh, let me write it, like Shailesh, Dr. Shailesh is a very learned person. So one network I will feed Dr. Shailesh is a very learned person. Another parallel network which is on the top, which you see, I will feed person learned very A is Shailesh doctor. Reverse I will feed. So both the way I will feed the sentence from start to end and then end to start. Both the way I will process it. So what is the advantage? One network is processing forward direction, one network is processing backward direction, which is from back to start. So that way, at any given point of time, I know both what is there from start to mid and what is there from last to mid. Both I know. So I'll be able to interpret. The meaning better. So that way, this is also one complex network of your RNN, which is called bidirectional RNN. So any questions on bidirectional RNN? Actually, these are only theoretical understandings. Coding as usual will be very simple. So any question on bidirectional RNN? This is the architecture which you can see. I want you to spend a couple of minutes and see the architecture. So one is feeding, one network is feeding with down network is feeding from S0 to Si. And other is feeding reverse. And both features are being fed to both. X1 is being fed to both, X0 is being fed to both, X1 being fed to both, X2 being fed to both. So like that, both start to finish and finish to start. Processing is happening at the same time. Why we do that? Because to interpret initial words, sometimes we need to know future words also. Otherwise, we will not be able to interpret, because language is a very complex phenomena. So, and we have to do interpretation by understanding the context. We cannot say take one word and take dictionary meaning of it and do the translation. It will not make sense. If we have to properly translate a sentence, we have to see in what context this sentence was told or written. And in that context, we have to translate it. Then only it will make proper sense. So to do that, both the direction we process it from forward to end and from end to forward, the same direction, same network. So that at any given point of time, we know both the side of the word. Suppose third word is there. So first two words also we know, and after is coming, that also we know. So that is known to our network. So this makes the contextual translations very kind of easy, and your translation becomes more meaningful. So even if you don't understand this diagram, it is okay, but you understand what is bidirectional RNN, which is more clear by this fish diagram. One fish is going on the right and one fish is going on the left. So this is what is the simple representation of a bidirectional RNN. So if you want to, this is the simple representation for a layman, and this is little technical representation which is in front of this.
So, sir, we can say that for images it is CNN we use, and for natural language it is RNN. Is that
RNN,
correct?
for RNN language, any sequence we use RNN. Time series, any time series we use RNN.
Okay.
And you got the basic architecture, right? Like I'll show you in once more to you.
Yes, sir. I got the basic architecture.
Very simple. Like these are the basic architecture. One I have not shown to you. Many to many in which you have input features not equal to output feature, which I couldn't show you because I couldn't get that in a search. So these are the basic things I wanted to take you, and if you want, we can do a couple of more minutes discussion on back propagation of these RNNs. If it is, if you have anybody has any questions on back propagation of RNN, we can take it up. And as you might have understood by now that vanishing gradient problem and exploding gradient problem, both are phenomenal of back propagation. They happen while at the process of they happen when we do back propagation process to update weights and bias. And this vanishing gradient and exploding gradients I have included in my lectures of advanced topics in CNN, advanced topics in deep learning. So that we'll cover in the last. And that time we'll cover in more details like why vanishing gradient happens, why exploding gradient happens, what are these things, what are its repercussions, what are its implications. So those things we'll discuss in the last. But in a nutshell, I have already told you, like if your gradient is fraction less than 1, and if you are multiplying it by weights, which is generally more than 1, it will reduce and further reduce. After some time, it will vanish, become equal to 0. But if your derivative is more than a positive number, say 1.21, 1.23, and if you multiply by weight matrix, which is generally positive. So weight matrix, if you multiply, it will get bigger, 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 bigger. And if you have too many number of layers, like if you have too many features, you will have very long RNN, and number of layers will be more. So it will multiply too many times, it will get multiplied by the positive number. So it will become a very, very big number, which will not be manageable for a normal computer. For any normal computer, it will not be possible for it to manage it. So these are two basic problems, and I think better than that, I cannot explain you what is back propagation. But if you have any specific questions, I think it can be more clear to you. If you have any more specific question, we can talk about it. Someone, you want to explain back propagation in your language?
No, sir. I think it's clear. Yeah, I don't have a different explanation.
Okay, Shrutika madam, Dr. Shailesh, back propagation.
Sir,
any problem?
As you said, I was having some question, which is not that important but as you said that maybe this more discussion will help us clarify this concept. So
what do you have question, madam? What question you have?
Yeah, so if let us say if we are having this RNN, and now you said that the loss, the final loss, it will be the summation of all the individual losses.
Individual timestamps,
of each neuron.
Yeah.
Individual timestamps.
Yeah.
So I was just thinking that I don't know, it may be illogical also, but because you said so, I am asking. So instead of summation, can't we do this for each neuron? Can't we do the back propagation by taking loss for each neuron? Like
Madam,
we are taking the summation.
See, there is a weight to weight, there is a neuron to neuron correction always, right? Every neuron to neuron correction will have a weight associated with it. Every neuron will have a bias. Okay, so we suppose there are 4 neurons and previous layer has 3 neurons and next layer has 4 neurons. So total there will be 12 weights, 12 weights, right? 12 weights, and how many biases will be there? Can you tell? 3 neurons in one layer. For next layer we have 4 neurons. So I told you there are 12 weights. 4 into 3, 12 weights. So how many total biases will be there in this structure? How many biases will be there? Anyone?
Sir,
See,
4
3
biases.
neurons are there in one layer. 4 neurons are there in next layer. I told you number of weights in between this second and third layer is say 4 into 3. 12 weights. There is no doubt about it. Okay. Now I am asking a next question. How many total including of these 2 layers, how many biases will be there? There are total 7 neurons. 3 in one, 4 in second. So how many total biases will be there?
Number of neurons.
7 biases.
No.
Biases will be only 2, right?
No.
Per layer, you are
7
going to add a
biases?
bias, right?
No, for every neuron we will add a
For
bias.
each neuron.
For each neuron we will add a bias scalar. So 3 bias for first layer and 4 bias for second layer. So total 7 bias we will have. So total number of trainable parameters will, how many total number of trainable parameters in this structure?
12 plus 7.
Yeah, 12 plus 7 is how much? Say 90.
90.
Right? So now you have 12 weights and 7 biases, right? And you have a loss function. You have a very complex loss function because loss function of every time step you have added up. So you have a very complex type function of a loss function, very complex loss function. It is there. Now this loss function, you will find a partial derivative of this loss function with the help with respect to each one of the 19 parameters. 12 bias, 12 weights and 12 weights and 7 bias. So 12 plus 7, 19 individual partial derivative will find out. 19 individual partial derivatives you will find out. You imagine how complex it is. 19 individual partial derivatives you will find out, and for each partial derivative you will get a minima to update that weight.
Yes.
So that is how backpropagation works. If suppose you have total number of trainable parameter, we talk 19 here. Suppose you have 1 million trainable parameters, such we get in RNNs, right? In CNN we get, right? In millions. Few lakhs, few thousand is very common in CNN. Million also I have seen, 2-3 million in some of my CNN also I got millions of parameters. So if there are 1 million trainable parameter, I have to find 1 million partial derivatives of the loss function. That complexity is. And that I have to propagate from one layer to other. And every back propagation I have to update the corresponding weights and biases. If you want, I can share with you one simple example of a 2-layer CNN, a 2-layer ANN in which back propagation is worked out. I think I have already given you in my PPT. If you open, there is simple 2-layer ANN is taken, and how back propagation works out, it has completely numerically it has been worked out actually. One article I have given in that, in which but complete back propagation has been worked out. So for 2 layers, if you do it, it will be very easy for you and you will understand what is going on. So I'll advise you guys to have a look at my ANN PPT and see the back propagation. I think I have marked it to back propagation in red to be taken later or something, that I have marked like that. So in red it is marked to be taken later. So I have marked in that article complete for a two layer ANN, complete back propagation has been numerically worked out. So you will be able to understand how it works. So if you want, I can do some more digging and I can share with you that particular article from my. Simply you have to open my ANN PPT, in that it is there. So if you don't want to do that, I will do it and share it with you. So you go through that particular thing so that you understand how exactly back propagation works. Okay. So actually, it's even for a two-layer ANN, it is very complex. And that's why for ANN, it is out of question, like out of the scope for this course to work out a mathematical derivation of for RNN. So far, any book I have read, they have not worked out back propagation. Everybody has given forward propagation, but backward propagation for RNN I have seen in no other book. No book I have seen it so far. Maybe some very advanced books or some paper may give back propagation for RNN. So far, I have not seen. Everyone gives RNN forward propagation, which is in front of you, very simple. And theoretically, they explain how back propagation works. So, Shrutika madam, is it actually theoretically, is it clear to you now how it works?
Yes, sir, somewhat clear.
So I will share that article with you. I'll take 5 minutes to see my own PPT. And in the group, I'll share that article with you today, in which for two-layer ANN, they worked out the back propagation numerically. So it will be very easy for you to follow that. So I'll share that today. Okay. So any more questions or any more things you want me to take up out of this? There are a lot of repetitions in this.
Actually, what are the features of, because for images and for data statistical and the mean deviations and all those are features, but for this natural language, what are the features? I'm not able to
Each
visualize.
word we take as a feature, yeah.
Oh.
Dr. Shailesh is a very learned person. So 2, 3, 4, 5, 7. 7 features are there in this. 7 input features.
Oh.
And suppose I am translating into French. And suppose only in 5 words same meaning is conveyed. So input features will be 5, output features will be 5 in French. I'm not French, I'm just taking one example. तो जैसे आप हिंदी में बोलना है तो शैलेश डॉक्टर शैलेश आई विल राइट इट डाउन डॉक्टर शैलेश बहुत लिखा पढ़ा आदमी है लिखा पढ़ा आदमी इसमें कितने गिनो अभी 1 2 3 4 5 6 7 इसमें भी 7 है तो इनपुट आल्सो से हिंदी भी in Hindi if I translate it get translated into Dr. Shailesh बहुत पढ़े लिखे आदमी हैं. So this also if I count it is 7 only. So it is just a coincidence. And English Dr. Shailesh is a very learned person, that also counts to be 7 only. So this in this input output both are same. So, but in some other language, German or say some other language, it may be 6 words only can see the same convey the same meaning. So that's where input and output will not be equal.
So in this training data set, one will be English language, and in means training where input will be
training data set will be both in English and French, or English or Hindi.
Oh.
It is a supervised learning problem. Okay, so both you will input, then whatever training set you have translation available with you, you will compare it with prediction, and then you will compute the loss. And for that loss, you will find out the derivatives with respect to weights and biases. Propagate it backwards to update your weights and biases till the loss becomes 0. Like your predicted and actual becomes 0 minus predicted, actual minus predicted should become 0 or near to 0. That is our aim, right? So that's how we train our neural network. Actual minus predicted should be either 0 ideally, or it should become as close to 0 as possible. So till that time it becomes 0 or close to 0, we'll keep updating our weights and biases. So that is training of our neural network. So that's why we need tons and tons of data to train a deep learning network or any RNN network or anything. So that is the biggest hurdle in adoption of deep learning architectures. Understood, no? So it is a supervised problem.
Means pura Oxford dictionary will be one of the set and their French
Oxford dictionary से कुछ नहीं होता है भाई, वो पूरा web ले लेते हैं. Those guys what will do? They will do web scraping. There are 100 websites. They will go to all 100 websites in the world. They will download all those web pages in English also and in French also. And that data, they will use it as a training data for their algorithm. Then only it will work. So I think OpenAI or some other company, they have developed one GN network which is available on payment method. In that they have trained their RNN, their network on entire internet of the world. Entire internet they have scrapped. They have taken that data and used it for training. Oxford dictionary is very small here. And see, if you take Oxford dictionary of English and if you take Oxford dictionary of French and try to convert, and if you want to train your neural network on Oxford dictionary plus its meaning on French, it will not be good because you will lose the context. Context समझते हैं ना, जो संदर्भ जिसको हिंदी में बोलते हैं ना, context. In both the dictionaries, context will not be there. So your word-to-word translation will be correct, but sentence-to-sentence translation will not be correct because your context is not there. संदर्भ नहीं है, मतलब जिसको बोलते हैं ना हिंदी में संदर्भ नहीं रहता है. That's why you need very large data sets of both the languages. First is English to French. Suppose you are converting from English to French, and for that you want to convert your RNN. So you need huge data set in English, and same translation should be available in French. Huge, both. Only English will not do because you need French also. Same translation should be available in French also, 1-to-1. Then only you will be able to compute the loss function, right? So it is a supervised training problem. So that is one of the biggest hurdle in adoption of deep neural, like neural network architectures, because it needs a large amount of, very large amount of data to train. Like similarly, if you are training CNN networks, you need, sometimes you need millions of images to train your CNN network properly. इतना million of images लाओगे कहाँ से भाई तुम? That's the challenge. So they scrape it from the world. Acha, even if you bring millions of images, training a CNN is a supervised learning problem. So every images you have to manually label that ये कुत्ता है, ये बिल्ली है, it is cat, it is dog, it is car, it is truck. Like manually you have to label it. All the million images manually you have to label it. And then only you can use it, that data for training of your CNN. Understood, na?
Yes.
Dr. Shailesh?
Sir, one more question actually.
Yeah.
Let us say these the architectures that you told, like one to many, many to one, many to many kind of. So when we are actually creating programming for these neural networks, and we are creating for each input, we are creating a separate neural network. So depending on the architecture, will there be some specifications that if it is one to many?
Madam, what happens? Suppose I will give you one example. I got your question. So let us take example of many to many. Okay, so many to many, suppose it is unequal, like input is your 7 words, features, output is only 5 features. So what you will do, both input and output vectors, you will define with 7 features only. Understood, na? So input vector will get populated with 7, but output will get populated with only 5. But at the time of defining, we'll define full dictionary, full word dictionary. So for input output will define equal 7, 7. But output will get populated with only 5 because there are only 5 output words. Understood, na?
Yeah.
So like that we manage. Yeah, like that we manage.
My question is regarding the intermediate layer, that H2, H0, H1 for
Yeah.
that thing. When we are creating those layers, then we will be defining that these will be the number of neurons and these things.
No,
while
no, madam,
programming.
no. It all internally taken care. If you were to define it,
Okay.
intermediate step, no, nobody will work with RNN. So it is all internally taken care,
Okay.
madam.
Okay.
Each internally
Okay,
taken care.
okay.
Yeah, all internally taken care. You don't have to define all those things. So when you
Hmm.
will do some
Okay.
examples which someone will take, na, so that time we will be clear to you how we define our RNN network, GRU network, or LSTM network, no. So that time it will be very clear.
Okay.
So that will take next week, not this week. This week we'll cover
Okay,
only
sir.
theory part. I'll share this PPT with you. You do your homework of reading some book or studying this PPT or do some articles from the internet or see some more videos. So come bolster, like make your foundation good in theory part by next week. And then next week we'll 2 days, Saturday, Sunday, we'll take RNN. A couple of examples we'll take, 2 or 3 we'll take it up. Many to one and many to many, both will take it up. Okay, so that is the agenda
I'll
for
be
next week.
missing. Yeah, I'll be missing those lectures. So later I will see the videos.
Yeah, I think why my only lecture? There are 1,000 more lectures available on internet. No, good lectures. You listen to them, you will get a different point of view also. Right? You will get a different point of view. So you can read some book, like if you have any deep learning book available with you, you can read that book. My book was very good, madam, for this, like very beginner friendly book. It is a very beginner friendly book which you can purchase just for 1,000 rupees. So those things are.
One question actually.
Yeah.
For this translation and all, there is a translator, na, Google Translator. तो फिर वो तो डायरेक्टली 1-to-1 मैपिंग करता है ना, ये स्ट्रिंग मैपिंग
नहीं, वो कॉन्टेक्चुअल होता है, वो 1-to-1 नहीं होता है, कॉन्टेक्चुअल होता है भाई वो। जब अपन नेचुरल लैंग्वेज प्रोसेसिंग करेंगे ना, तब तुमको समझ में आएगा कॉन्टेक्चुअल, हाउ द कॉन्टेक्चुअल मीनिंग इज टेकन केयर। तो कॉन्टेक्चुअल होता है वो, इट इज नॉट वर्ड टू वर्ड। वर्ड टू वर्ड करेंगे तो क्या मतलब है यार?
ओके ओके,
मैं बोलूंगा कि मतलब अब छोड़ो ना, आई एम नॉट गेटिंग एनी गुड वर्ड, and which words which I am getting I cannot record on like this, so leave it. But every word to word translation if I do, there is no meaning, na. Anybody can do that, right?
Yeah.
Any machine can do that, so that is not a fun is you understand the context and then in the same context you translate into other language, so that meaning doesn't change. So that's what the fun is, right?
Yes.
So that's where real art is. Okay, any more questions please?